Welcome to our final presentation. Our official title is Advancing Knee Arthroscopy Surgeries with Endoscopic and B-Mode Ultrasound Imaging.
So, welcome to our presentation. In this presentation, you will hear about some background regarding our topic, the methodology of it, and the results we obtained, and finally the future work that would be able to just be derived from it.
So our background. So this project started with a common interest in sport injuries, motivated by the number of peers sustaining joint injuries during all types of activities, but most commonly sports. It developed into a curiosity about treatment options and narrowed down to the specifics of arthroscopic knee surgeries. Initial research and planning was conducted towards the goal of finding a way to improve the effectiveness of arthroscopic knee surgeries. For research data demonstrating the current procedure had generally short-term benefits, despite being one of the most commonly performed surgeries. It is inferred that the benefits of the knee surgery only last short terms because the surgery does not completely repair the injury as the visual field is constricted. We set a plan to design the solution for the limited scope of view, a combination of internal and external ultrasound devices strategically placed to navigate the cavity of the knee. With the improvement in visibility, it's strongly theorized that the arthroscopic knee surgeries will have longer lasting benefits as the procedure itself would become more accurate. So knee surgery is a $3.2 billion business, with the average surgery costing more than $5,000, and it is performed worldwide more than 2 million times each year. From an analysis of 9 studies, most participants reported that the benefits of surgery did not last for more than 24 months. To deal with this issue, we've combined the usage of interior and exterior ultrasounds during arthroscopic knee surgeries to increase visibility during the procedure, therefore making the surgeries more accurate and precise.
So our methodology was split into 3 main sectors. First, the literature review of previous works investigating the status quo of knee arthroscopy and the problems it presents. So this combined with articles of ultrasound technology as well as how it could be used in arthroscopy. Then a 3D model of the knee was developed in SketchUp, and 2D cross-sectional images were captured from this model and then uploaded into the simulation program as imaging targets for the ultrasound imaging tests. We developed a simulation program to mimic ultrasound arthroscopy implementations for optimizing the design of arthroscopic devices for knee surgery. The simulation was built in MATLAB on the basis of an ultrasound propagation simulation toolbox called K-Wave, and then a series of new functions were then developed to build ultrasound transducers for imaging inside the knee.
So our project started with the research on the knee, for my partner and I needed to understand the anatomy of it before introducing an interior ultrasound to the knee cavity. After consultations and multiple revisions, we drafted 2 2D models of different angles to visualize the placement of instruments on site. 4 instruments are shown here: the trimming device, viewing scope, exterior ultrasound, and lastly, our recommended interior ultrasound. Then we expanded from the original 2D models onto 3D models with slight modifications of instrument placement. 3D models were useful in bringing the design off the page, for we could rotate and control the angle and proximity of each muscle, tissue, ligaments, and instrument. This model gave us something to work with in terms of coded simulation work, as we took snippets of the 3D model and inputted it into our code.
And these are the results from our ultrasound simulation. On the left is the ultrasound image that we captured using the simulation in MATLAB, and on the right is the target image that we used. So the target image is a screenshot from a cross-sectional view of the internal knee cavity in the 3D model, and it has been adjusted to reflect the density and sound speed qualities of the actual material. And then on the left is the simulation result, which shows the simulated outcome of using using an arthroscopic ultrasound to scan this area.
So our future work is that with this project, there's an abundance of room for future development, both in the short and long term. From here, it is possible to refine the code further and evolve it into a more user-friendly online simulation platform for rotating arthroscopic ultrasounds, which can be applicable in a multitude of scenarios, both related to knee arthroscopy and not. Furthermore, with a more powerful computer, it will also be possible to both create a more sophisticated complex model of the knee and run it within the simulation. This will provide for more detailed information and a more comprehensive view of the knee cavity. Finally, in the long term, with the correct resources, we could construct a working prototype of the ultrasound and eventually put it into practice in clinical settings. These are our references from our literature review, and thank you for listening.
优秀